Hi guys, this is Anski. We're gonna be taking our first session today in coding in Java. We will be covering today data types. Those are effectively just sort of like a containers, we can call them. It's effectively how do we store data and how do we store information. So those could be numbers, those could be decimal places, those could be true or false answers, and those could also be text or characters. So this is effectively what we're gonna be cover today. However, there's one thing that we kind of have to mention, which is it's a bit more complex than that. Why do we actually use data types? What's the point of them? Why do we have to remember them? And how does this work in general? Now, this is an important part that we kind of have to look at and kind of understand deeply what data types are. So this is something that we're gonna look in the slides in just a second, and we will effectively discuss it further there. We have two different data types. We have one primitive data types. Those are usually if you coded before in any other language or done any degree. It should be very simple and straightforward. There's the booleans, there's integers, floats, double, and so on. And there's also non-primitive data type. Those contain classes, those also contain arrays and strings. And we will talk about those a bit in upcoming few videos, because it won't take us only one video to cover them deeply enough as I would like to. So without further ado, let's just jump right in and let's talk about data types and code them in. Right, so data types, let's look at them. So effectively, data types are a way to tell the compiler how our data will be used. So we will be counting the numbers. For example, if we have bank account and we have numbers like, let's say 52.27, and we add 1.2 as an example. Or are we going to store some kind of information like in form of a text? Are we gonna be creating sentences together, and so on and so on? Our computers only use binary, which means they only use ones and zeros, which means compiler is the one who needs to understand what did we code, what did we create, and be able to pass that specific information, restructure it into a binary code and tell the computer and send the data across the entire computer into a memory and so on and what needs to be done. So we have two data types, as we mentioned. There are primitive data types and non-primitive data types. Today we'll be focusing mainly on primitive data types, and in coming few videos we're gonna look at non-primitive data types. Those are a bit much larger. It could be covered in effectively one session if we kind of cover basics, but as I kind of want to go deeply into that, we'll effectively take a bit of time on doing those. So primitive data types, we have byte, short, int, long, float, double, boolean, and character. So our primitive data types effectively split into a different functionality and also different sizes. So functionality would be byte, short, integer, and long would store a number, a full number without any decimal places. This could be 5, this could be 10, this could be 100 or 100 billion. Float, double are the ones that store any decimal places. So that can be 5.27 or a pi number. Boolean would store always true or false answer only, and character would store just singular character. Now, why do we have so many different? So this is a functionality. Let's now talk about the sizes. In order for the computer to not force us to store, for example, a lot of amount of memory. So if you think about it, number 100,001, so 100,001, and the number 1 would be much bigger. So the size would be different. So we obviously would need way more memory to remember 100,001 than just 1. So this is where it comes in with our effectively different data types. So we have byte, short, int, and long. Each one of them stores a much larger number. So for example, byte would only be able to store between negative 128 and 127. If we would want to make 128 number and store that value, we would need to use short. Byte would not be able to store anymore such a large number. This allows us to be a bit more conservative with our memory and make our programs more efficient. It's not of a problem anymore right now due to the sizes of our computers, and our computers usually have a lot of RAM and just able to store a lot of information. So it's not of a problem anymore. But back in the day when our memory was so tiny, we had to focus really deeply on how would we use our memory efficiently. It's still useful if you can create the programs, especially very large programs, to focus on the memory, but usually these wouldn't be a very small projects. This is over here you have an example of what the kind of values we can store between each one of them. So for example, long would be way above int. I think it's like in trillions. Floats are usually less precise than doubles, and doubles are usually more precise. So it depends on what you effectively need to store. Now, one of the things to mention, we don't really use so often byte and short. We store stuff in int unless we really focus on memory efficiency. Character can only store a single character, and this is an important part to remember. We cannot store multiple characters in a char. We only can store one character. This can be A, this can be C, and so on. Those values are then used in an ASCII table and then later on transferred to a character. So this is how our computer understands. It's effectively based on a number, either decimal number or a hexadecimal on ASCII table. In order for us to create sentences, we need to put a list known as strings just together. So we have multiple characters and they just effectively put in a list and then just read as a sentence. That's pretty much it. If you think about it, even in English, we do the same thing. We have alphabet. And then in order for us to use a sentence, we need to choose the numbers, characters from alphabet, put them together with spaces and so on, and then be able to read the sentence. Right, so right now, let's jump into coding and let's try some of these things out.
Okay, perfect. So we're gonna jump right into our IntelliJ. I am gonna be using IntelliJ when it comes to coding in Java, because this is one of the most commonly used and the one that I'm actually used to. You can also use Visual Studio Code or Visual Studio, whichever you prefer, whatever actually makes you most comfortable. As long as you know how to use it, that's perfect. I will be probably creating some of the videos sooner or later on how to use IntelliJ. The reason for that is because we would start also focusing on testing part of our programs, and for this we'll be using Maven, which is mainly in IntelliJ. Right, so the first thing I need to mention, we have classes in Java, we have methods, and we also have packages. Packages are effectively just folders like main java ansky.un. .un effectively stands over here that there is a folder called ansky, and there's also a folder inside that folder called an, and there is nothing in there, so there is no other files. If we were to create a file inside the ansky, then effectively this would be just ansky and then file and then also folder an. The folders are just called packages, that's all. So this is our first line over here. It just says that our app program, main script is effectively in package ansky.un. Then there is a class, public class main. Those have to effectively be the same name. So this should be also be the same name as our script name. Script name is just effectively this. It's just a file. So effectively, we need to ensure that this is always the same name. Otherwise, it's going to cause us an issue. So if I type main over here, we're going to see that there will be a problems over here. Then we have methods, which is public static void main method. This is our first method, and this one method is a special method. It will always has to be in our Java. This is effectively something we call our runner. It runs the program. This is effectively, it's kind of like a starter. Once we run our program, no matter how many scripts we have, so how many files we have in our program, this one will be the one that starts and runs everything. So effectively, we're not going to be coding too much in the future in main. It's not really good to have a lot of information in main, and we're going to be splitting that across different packages and across different scripts. But for now, we'll only focus on main because it's right now we are still on the basics. We'll also talk about what string array of arguments is in the future, once we kind of cover what the strings are, what the methods are, what the classes are, and so on. So let's just dive right into our data types. So firstly, I want to show you byte. So if I type byte, this is effectively how we code data types in Java. Firstly, we have to specify data type. So whether this is a byte, whether this is a short, whether this is an int, boolean, and so on. And then, so in this case, we're going to start with a byte. And then the name of it. So this can be, for example, I don't know, what can be between 127. Maybe let's just put just number for simplicity. Then we can effectively always we put semicolon. Semicolon means this is the end of the command that we are effectively inputting into our program. Our compiler will look for those semicolons to understand that this is one command. And for example, if I put byte number 2, this is the second command. Okay, we can have as many of them over here as well. We can also make enters, whichever prefer. Usually we will just make enters for the readability for other programmers and ourselves in the future. Okay, so this one right now is we just created effectively a number. For you to run the program right now, so if I'm going to run this right now, it's going to give us an error. What you would tell us is that the number is not initialized. So this is our path to our program. And over here, it just tells us that it has finished with exit 0. So effectively, we didn't get the error. The reason for that is because we haven't used it. If I'm going to hover mouse over it, it's going to tell us variable number is never used. So let's use it. In order to print something in outside our console, over here, we use command system.out.println, and then we can put a name of our variable. Now, one of the important things over here, the name is the same thing as in maths. You know how we use x and y? This like they represent a value. So number is effectively, or whatever we call it, just represent any value. We could even call it John. It doesn't really matter. But in this case, we're just gonna call it number. What you're gonna see is already the first thing is we're gonna get red over here. It's gonna say that the value has not been initialized. What it means, it doesn't store anything. The compiler knows this is a byte, so it knows it's a full number. It knows it's gonna be between -128 and 127, but it doesn't understand what it's supposed to store there. So this one is effectively unknown. It's so-called null. So if I run the program right now as well, it's going to give us also the error. So if I run it, and it's going to say a variable might not have been initialized. Okay, so one of the things before we're going to initialize it, I kind of want to talk about system.out.println. So this effectively allows us to print anything inside to the console. So if I just type console and I run this, it's going to print over here console. Okay, this we can say also hello world. It doesn't really matter whatever you want to print. We can also print variables. So I can just type number and it would work if our number would be initialized. Now, this is one of the cool thing about IntelliJ. Instead of us having to type system.out.println all the time, we can print, you can just type SOUT, so SOUT, and then just hit tab and it will effectively run the same thing for you. So this is one of the reasons why we also use IntelliJ, because it has a lot of different macros. All right, so let's focus right now on our initialization problem. So if I do byte number, we created a variable called number, but it has nothing in it. So what we can do right now is we can just type our name of our variable, space equals. We don't have to make a space, by the way, it can be without a space, it doesn't matter. But for readability, we're gonna write space, and we can just put any number we like as long as it's in range. So let's put 52. Now, as you're gonna see, the red squiggle is gone. If I print it out right now, so if I run this program, it's gonna print 52, which is perfect. This is what we want. The second way of initializing, because we can cut this into one line instead. Instead of doing this, we can put over here numbers equals 52. So we can initialize instantly as we create the variable. So if I to run this right now again, it will work just fine and it will work perfectly. Okay, what happens if I try to put 200. What it's gonna say, if you're gonna put my mouse over it, it's gonna say require byte. So it requires the memory of 1, which effectively is between negative 128 and 127, but we provided an int. The program effectively, when it comes to memory, it will always assume that we are trying to pass an int because it's just one of the most commonly used. So if I were to change this right now to int as it asks me to do so, it will be completely okay. So then if we run this, it's gonna tell us 200. Okay, that's the same case if I'm just gonna input a very long number. So next variable we're gonna talk about is char. Char stands for character, and we once again have to call it, let's just call it letter, and we have to put a single quotation mark over here, and we can just put any value we want. So if I do south again and then just try to print letter, it tells us that the letter is A. Letter is A. Next one is also Boolean statement, which can be true or false. So first you're gonna write Boolean and then, for example, answer to the question. As you can see, I'm writing in a camel case. Camel case effectively means that it starts with a small letter, and each time we have a new word, we make it a capital. So that way, whenever we read it, we can say answer to the question, instead of having something like this, where, whoops, just a sec, like this, where this would be much more confusing. You still could be able to read it, but it can become very confusing. So that's why we just make it capital letters like this. And then we can assign either true value, or we can assign false value. So if I to print this one right now, it's gonna give us this. So it's gonna give us false. It's gonna print out false. If I would change it to true, it will print true. So this is one of the things that I kind of want you to focus on and be able to work with those different values. Once we gonna cover strings, before we jump into classes and methods, we'll discuss a bit about arithmetics in IntelliJ or just in Java in general. What this effectively means is that if I create number 2, and I'm just gonna give you a quick preview, I could effectively over here, so if I'm gonna delete this just for so it's cleaner, and I say number 1 plus number 2, and I run this right now, it's gonna add them up together. So it's gonna be 202. We'll look more into those as we kind of upcoming few videos. I would like you to try to focus to create different numbers, play around with different data types and get used to them. One of the things that we kind of always use is either double. We used int, we use boolean a lot, and sometimes we use characters as well. However, it will be very useful for you to be adjusted and able to use many different variables, and always you can explain that it's the memory efficient. Okay, so effectively this will be your first challenge, and I know it's not a big of a project, but as soon as we're gonna deal with strings and methods and classes and many different things, we'll start working on our programs as well, where you're gonna have different programs each week. But for now, I just want you to get very, very familiarized with data types and how you create them. As this is one of the most important part when it comes to coding, we're gonna be creating a lot of data types. A lot of information and storages and data. Just gonna create all of them. So good luck. I'll see you next week. And I hope this is gonna be incredibly helpful to you. And if you like this video or if you have any comment that I can improve, just leave it in the comment, share, subscribe. Thank you very guys and see you. Bye bye.